Okay, so this is back-to-back testing of two Schweitzer SEL 2595 DTT transfer trip modules. These modules basically take 8 input and have 8 outputs, and they are converted into C3794 that normally goes over a telecommunication network. So what do we have here? We got a function generator generating something like a 12 volt peak to peak around 1 hertz or 1 or 2 hertz or something like that. It gets fed into an input on this. That's why you see the input one sort of flashing in and out. And now I have the DTT modules back to back over this fiber here, and as you can see, it's going through a coupler, and it's going into the second module, and then it gets presented here as a contact closure on the whoop, this is the input. The output is right here, sorry. Yeah, there you go. So this is the output one. And to make sure that everything is okay, I also have, as you can see, the control switches of the output module, and then the control switches on the input module. And one of them is actually has the internal clock. And you can see here that the output is down there. Oh, this is the input. The output is up here. And I can display this on the scope right now. So what you see on the top there, and let me give you a better view here. There you go. All right, so the top view is basically the input. The bottom view is the delayed output. So I'm going to zoom in to measure the actual delay. There's a little bit of noise because that comes from the counter on the output. So the measurement here shows per the SEL spec, the back-to-back, it will be below 5 milliseconds, and we can see the output varies somewhere around 4 point, let me see here. All right, so this is like maximum 5, but let's move this to the minimum value just to see. It's right around there. So around 4, there you go. Somewhere between 4.1 millisecond to 5 millisecond back-to-back, and probably has to do with the framing. And the input voltage, as you can see here, is about 10 volt, and the output is just a measured contact, so I'm not too worried about the voltage there. That's something that I measure on the counter. The other thing I have here is counters that I set up, and the counters, the left one here is an input counter. They have to have a little bit of a transistor logic because it needs a little bit of a pull-up to measure this. So as you can see now, the counters are equal, 27, 25, whatever, but the output counter's on the right, the input counter's on the left, and we've been running this. And I can actually increase, let me go down here. The spec on the DTT module is up to 10 hertz, so I can really send 10 trips per second, and that's what I'm going to try to do here. So let's go up there and measure frequency. Alright, so now as you can see, it's around right there, 9 hertz. So that's a little bit below 10 hertz, but it allows me to send a large number of trips and see if any trips get lost. And as you can see now, it's running back to back, and I've sent something like 3,000 trips so far. Let me slow it down. So I've sent around 3,000 trips, and it's not losing any trips as expected. So everything is running fine back to back, and conclusion is that the transfer trip of this module back to back is below 5 milliseconds per the Schweitzer spec. All right, so the next step will be to actually put this over an XTran network, over a pair of fiber in the ring. All right.